Hello everyone, this is Simon from the Redis Developer Relations team. It's the 18th of August 2022 today, and I keep promising we'll use that sign in a stream, and we'll get there. Hopefully we take a step closer to that today. So yeah, welcome to Things on Thursdays, which is a hopefully recurring series where we're going to look at Redis concepts or use Redis with Internet of Things devices. So as I've said before, that there behind me is a flip disk sign off of a bus. It's got a Raspberry Pi in it. We'll use that at some point. We're going to attempt to use Raspberry Pi today. We tried this before during a heat wave and found that you get thermal meltdown on a laptop when you put too many things through a MacBook Pro. So I've made some changes today. We've got the Raspberry Pi. It's on a second camera on a second computer, and we can bring that onto the stream as if it was a guest. So hoping that relieves some of the load. And we can actually get on with what it was that we wanted to show you, which let me swap around here a minute. Bring the desktop up. So you can see down below me there at the minute is a second camera looking at a Raspberry Pi. That Raspberry Pi has actually got an LED matrix on the front of it. So it's got what's called a hat, which is an easy to attach piece of hardware that plugs into the expansion pins on the Pi and gives it some new capabilities. So this has got an 8x8 matrix of LEDs. They're multicolored and they have a Python API for coding against them. So one of the sort of Redis concepts that is quite fun to represent visually is the bloom filter. And we'll look at what bloom filter is in a moment. But basically, if we've got something that looks like this is the actual product I'm using here. It's called a unicorn hat from a company called Pimeroni here in Sheffield in England. They're currently 45% off. So if you're interested, now's a good time. This product here is really good for representing a bloom filter because essentially a bloom filter is an array of bits. So they can be on or off. So we can turn the LEDs on when there's like a 1 in a particular bit, turn them off again when there's a 0. And because this is a multicolor product, we can do different effects for things like, oh, I'm querying whether the current bit is set or not. So you can actually see the mechanics of how that algorithm works. So hopefully that'll be fun. I have got an article here that covers this project in detail. We won't go through it in blow by blow detail here today. The article does if you wanted to like go set up your own and build it. But what I wanted to look at was how this works, how it works on the Pi, and then see if we can start making some steps to remove its front end, which is currently a Flask application and a website, and replace it with that code that we wrote a couple of weeks ago in Python that looks like the Redis server. So it answers Redis CLI with Redis protocol commands, and we can talk to it. So yeah, that's what we're going to take a look at today. The article can be found here, and also we have Suze today working in the comments. So if you have any questions, feel free to ask them, and they'll be brought to my attention, or I'll check periodically and pop them up. And also, yeah, we'd love to know where you're dialing in from. We're here in Nottingham, England, and it's currently rainy after a bit of heat wave, so that's kind of a good thing right now. So what I want to do is quickly do some concept stuff and then demonstrate what's going on with the device down below. So if we switch here to, that's Visual Studio. Let's switch to something else. Let's switch to QuickTime here. And I've got the iPad connected. Let's see if we can do some drawing. So what I want to show here is, get my pens, is what a bloom filter roughly looks like and what the point of it. So we've talked a lot about these recently on stream. So between myself and especially Savannah on Tuesdays, if you check out Savannah streams in Snakecase, which you can find on our developer relations events page, then you'll see that she's been building an interface that compares and contrasts all the different probabilistic data structures in Redis. So First off, what are probabilistic data structures? They're basically data structures that trade off some accuracy for a lot of something else, so speed or storage space. And why are we interested in losing some accuracy? Because sometimes we might have a data set that is so large we can't fit it into memory or the available data or the available disk or whatever, or it just never ends. So it's like a constant stream of tweets or temperature readings or something. The probabilistic data structures allow us to get a good approximation on things about that data without having to store all of it. The Bloom filter is often used in place of a set. So its purpose is to check set membership. So have we seen something before? So we put things in there. So we'll look at like names or something, and then we check if we've seen them before. And it will tell us, no, I haven't seen that before. And it will be very certain about that to be right. Or it'll tell us, maybe I've seen that before. And it can't tell us for sure, but it basically has a strong possibility it's been seen before. And that's the sort of probabilistic trade-off. And the reason for that is it hashes the data away rather than storing it, which is where it saves all of that space. So if I were to draw it, a Bloom filter looks something like a bit array. So if we had something like this, and we have lots of bits in here, and say that's our Bloom filter. So we have like bits 0 to whatever the size of the Bloom filter is, 0 to n. And imagine we wanted to put some data in there. So we want to store the identifier Simon. And the way the Bloom filter works is we're going to run each identifier or each thing that we want to store through a number of hash functions, and then mod the result of that hash function, which is a number, into the size of the filter here. So we'll basically get a number between 0 and n. So if I have like h1, 2, and 3, those are my hash functions. Imagine that I hash Simon, and Simon hashes to, like in H1, it comes out to this position here. So we put a 1 in the Bloom filter, and in H2, it comes out here. So we put a 1 in the Bloom filter. H3 comes out here, we put a 1 in the Bloom filter. So we stored Simon, and it's kind of like not taking up any additional memory because we'd assigned the width of this filter already. So if I then go and put in some other data, so if I wanted to put in, for example, let's say Justin, let's imagine Justin hashes to here. So we put a 1 there, and hashes to here. So we put a 1 there. And then let's say it also hashes to here. So we already had a 1 there. So that's okay. That just means that for that hash filter or a hash function, we've got a clash and the bit was already set. So let's then add somebody else. So let's go ahead and add, for example, Suze. And she hashes to there, and let's say all the way over here, there. So as you can see, as we add more things, we get the odd clash. We add we set more bits to 1, but the size of our Bloom filter doesn't grow. And there's obviously some tuning you can do here with the size of this bit array and the number of functions, and there's some math you can do to get an accuracy or a desired accuracy. And that's where you play the trade-offs a little bit between how much space you're going to use, how accurate is it, but it's still going to be a lot less than storing all of this stuff in the set. And in the Redis world, Redis Bloom has a Bloom filter that will handle all of this for you. You tell it a desired error rate or an acceptable error rate and an anticipated number of things you might want to store in there, and it will scale this thing appropriately for you. So now we put some stuff in there. How do we can't get it out because now it's just hashed. So we can't say what's in the Bloom filter. We can't get Suze, Simon, and Justin out again. They're gone. They're hashed away. But what we can do is say, are these things in the Bloom filter? So if we ask it if Simon's in the Bloom filter, then we run Simon through those same 3 hash functions and basically check what's at each of the positions. So if we get 1, 1, and 1, then we can say, yes, Simon's in the Bloom filter. Except we can't really say yes. We can say, yes, strong maybe, because we'll look at why that's the case in a minute. But so that yes is a probably yes. And then we can ask it something like, is Steve in the Bloom filter. And let's imagine Steve hashes to this position here. Well, there's nothing set. So we can say absolutely certainly that Steve is not in the Bloom filter, because if we'd have put Steve in there, something would have hashed to that position. And had this position, let's play along a minute, had this position been a 1 and the next position was here, then we'd fail at this point because we've got a 0 and so forth. So basically, the minute we hit a position that's 0, we know for sure Steve's not in there. And then let's go and try the other case, which is, so we've got a definitely no, a probably yes, and then something else. We've got, hi Dan, sorry Don, we're talking about Bloom filters here at the minute, which are a probabilistic data structure. So we've got Simon here is a probably yes, it's in there. Steve is a definitely no. And let's try Savannah. And let's say Savannah hashes to this position over here. So that's a 1. And this position over here. So that's also a 1. And this position over here. Well, that's also a 1. But we didn't actually add Savannah into the Bloom filter. So the reason why we can say Savannah is probably in the Bloom filter, and in this case we're wrong, is because everything hashed to 1s, or positions that contain 1s. So you do have the scope for getting false positives here, which is part of the trade-offs. We're saving a lot of memory, but we might have some false positives. So that's basically the data structure that we're looking at. How does this relate to the Raspberry Pi? Let's just clean up and start again. Well, the way that this relates to the Raspberry Pi and what we're going to show is we have got this thing attached to the Raspberry Pi, and it is I won't draw them more, but it's basically got 64 LEDs. So it's got like 0 to 7 in this direction and 0 to 7 in this direction. So if you unpack that into a sort of row, it kind of looks like that bit array. So if these are 0 to 7, and then back here is like 8, 9, 10, etc., we've got a 64-bit array of positions that happens to be in an 8x8 cube. So that's what we're going to use to represent one of these. And we're going to take a look at how you can build your own. Obviously, this is kind of fun exercise with a bit of hardware. You wouldn't build your own and put this into production because it's going to be super slow and maintenance. You'd use a product such as Redis Bloom, but we're going to play with this and sort of explore how it works so that you get an appreciation of how the product works. So I'm going to get rid of QuickTime here because I don't think we're going to do any more drawing. And it frees up some resources, which, as we've learned, is a good thing when you're live streaming. So what have we got now? So we're going to look at these lights below us on the Pi, and we are going to control them through some Python. And I have a pre-existing project that we're going to look at. And then we may be going to look at, depending on how time goes, moving that project to something that the Redis CLI or code that understands Redis and uses a Redis client could use. So we get a sort of fake Redis that only does a Bloom filter inside this Raspberry Pi. But first off, let's do a little bit of demo. So what have I got here? I've got Visual Studio code. I've got some Python code that I wrote to drive this. And it's a Flask application, and it has a really basic front end that allows us to interact with the Bloom filter. And you'll see what happens down below when I do that. One thing that's really cool about Visual Studio Code is you'll see up here, I'm connected by SSH to the actual Raspberry Pi. So I don't have to shell into that or open a virtual desktop or VNC into it or something. I can directly edit the code in an environment that I'm familiar with. And also this terminal down here is connected to the Pi. So I can also run it and do all the cool VS Code things. It also does port forwarding. So we'll see when I start this up, I'll be able to access the web application as if it was running locally. So let's get to the demo stage here. So I'm just going to go start this. I need to do flask run. Tell it to bind to all the IP addresses. We're going to run this bit. Didn't like that. Why did we not like that? Oh, because I can't spell. There we go. Double minus, not single minus. So I've run something in the terminal here in VS Code, and that terminal is running on that Pi below. It's not running on the Mac that I'm using to talk to you through. What's happened immediately is the code started up, Flask started a web server on port 5000, it started to listen there. And VS Code has picked up on that, and it says, do I want to open that? So if I open it in the browser and bring it up here, what we get is the front end for this. So again, VS Code making our lives very easy working with these devices. It's pretty much like working on your own machine, except I've got the benefit of I can write code that interacts with the extra hardware on the Pi and debug it. So the Bloom filter here has kind of like three things we can do with it. We can add something to it. We can have a guess at or ask it, do you think something exists? So has it been put in there? And we can reset it, which is clearing it all out. So I don't see any LEDs on at the minute. So that normally means it's empty because the bits are 0, then the LEDs are off. So let's hit reset. And what you'll see there is that it reset itself. And also, it's probably better TV if we do this. So now you can see the Pi more easily and the front end. So what I'm going to do now is broadly do some of those operations that we did on the iPad with the drawing and add some names to the Bloom filter and see what happens. So this one also has 3 hash functions. So for every name that I add, so if I start by adding Simon, what we'll see is that hashes to 3 different positions. And there we go. They flash green, showing that that's the positions they've hashed to. And then they turn red and stay red. So what's happened here is we've now set 3 bits in the Bloom filter. And those are the bits that Simon hashed to. So if we go ahead and add somebody else, so let's add like Justin. You see Justin hashes to 3 different bits, and those have now been set. And then let's add Suze. And Suze hashes to 3 bits, but one of them was already set. So we've got a sort of partial hash collision there in that Suze only set 2 new bits, but this is okay. And then let's set Savannah, and I'll do one more after that. So Savannah has 3 new bits, so they go green and then red. And then finally, we'll do Steve. Again, Steve has 3 new bits, and that is all good. So going onwards, what we can do now is ask the Bloom filter, do you think that something is in there? So if we say to it, Simon, the first thing we added, does Simon exist? What it's going to do is it's going to run each hash function. And what you'll see on the Pi is that it toggles the bit that that maps to see, to show you where it's looking. And then if all of them were set, so all of them are currently red, it'll say, yeah, Simon may exist. And if it finds one that wasn't set, so is currently off, it'll come back immediately, not try anymore, and say, no, Simon definitely doesn't exist. So let's see if Simon exists. So there it goes, toggling bits. So it's tried that one, it found it, tried that one, it found it, tried that one, it found it. And now the front end comes back and says, Simon may be in the Bloom filter. So again, probabilistic data structure. Can't say for sure that Simon's in the Bloom filter, but might be. There's a strong chance of that. So let's try another one. Let's try Justin. So we would expect to get a maybe for Justin. So there it goes on the first bit, the second bit, and the third bit. And yeah, Justin may be in the Bloom filter. So let's try a member of our team that we didn't add to the Bloom filter. So you'll see Guy on stream periodically. So did we put Guy in the Bloom filter? Well, straight away, it's toggled a bit that wasn't set. So it's not going to go any further. And it says, and it can say this with absolute certainty, that Guy was not added to the bloom filter because the first hash function didn't hash to a position that was already set. Therefore, Guy could never have been added to the filter. So you'll notice that as we add more things, so if we add a Stephanie, for example, it's not a function of the length of the name or the identifier we're adding. It's the number of hash functions we're using that controls how much storage we take. And if I keep adding a few of these, so if I add like Simon again, we shouldn't get any new bits set. There we go. And let's just add a couple more. Let's add Frederick and 3 new. So what you'll see is we're filling up this bloom filter over time. There are strategies, and Redis Bloom, the product, will handle these for as your bloom filter fills up to kind of put another bloom filter next to it and start stacking them. And we're not going to go into that today because this is kind of like a fun demo with the Raspberry Pi. So how does this stuff work? What I'm going to do now is swap back to here and swap back to VS Code here. So what you'll see down here is every time we've been adding someone, the way that I built this project out was it has an API. So the front end that we were using, the web front end, is just making post requests. So you could use this from another application if you wanted like a really slow bloom filter that had limited capabilities but was kind of fun to look at. You could use this and just send HTTP post requests in. So here I'm posting to API add and then Simon, the identifier I wanted to add. And we get some debug output here that tells us what which LEDs the 3 hash functions map to. And somewhere here you'll see, there we go. So we get an exists route that will return true or false, and you can see when it does or doesn't exist because it will stop as soon as it finds 1 bit set. So when Justin exists, it stopped after it found 18, and Guy, who didn't exist, it had to go the full 3 things, so it couldn't shortcut that and say, oh no, Guy doesn't sorry, it can't shortcut it because it has to check all 3 functions. So this is the interface that we've got at the minute. This is it running on the Pi. Visual Studio is talking to that. Let's just have a quick, put the terminal down a little bit and have a quick look at how this works. So this isn't an exercise in understanding Flask or Python necessarily, but if you wanted to build one of these data structures, we have basically got a few dependencies that we're using here. So I'm using the Murmur hash library. That's a library that gives us hash functions and saves us having to write our own. One of the good things about using a library for this is maths is hard, and people have done that for us. And also what you want in a hash function here is one that generates a good distribution. So if I've got like 64 possible slots that I could drop things in, I want a hash function that, given different identifiers, sprays the result all over those 64 and doesn't focus in on one block, because then that bit of my bloom filter would fill up really quickly. So yeah, we've got some preamble here. I'll just show quickly how to work with the LEDs. Yeah, that's obviously specific to this LED product, which, as I said before, it's called a unicorn hat from a company called Pimeroni. They provide this Python API for it, and we can basically work with it at quite a high level. So there's various versions of this product. So we basically figure out which one we've got by asking it. So I've got the 8x8 one, there's a 16x16 one, there's others that are rectangles if you've got like a Raspberry Pi 0 or something that's a different shape. And I can set the brightness. These are extremely bright, and I'm using a diffuser. So that case up there, there's actually a solid piece of plastic in front of the LEDs that diffuses it. It's a bit like car window tint. And even with that, I'm only using 19% of the brightness of the LEDs. It keeps the power consumption down, which is important with pies sometimes, but also it saves your eyes. You can properly hurt your eyes if you're going to turn these up to a very high level. So I think this actually warns you as well if you go too high. And so, did you really mean to do that? So yeah, and then we have some code that just figures out how many LEDs have we got. Because I wanted to make this fairly flexible, so you could plug in other LED matrices, and it will work out, how many positions there were and adjust all the calculations appropriately. And I'm going to pop down to something higher level here and just sort of show what happens when we call one of the routes that actually does things. So when I'm adding an element, I have an add route. And basically at the minute, I'm just returning a JSON version of whatever this add to filter function returns. So let's take a look at that. That's not doing what I thought it would for a minute, but there we go, add to filter. So when we want to put something in the bloom filter here, what we do is, we need to do something for each of the hash functions we've got. So I've got a loop here that goes through each of the hash functions that we've got, and it calls the murmur hash API on that, and basically says go away and hash the element and modulus it by the number of LEDs. So the hash function will generate some number, and then we need that number to be within the range of the LEDs we've got. So in this case, it's like 0 to 63. So I have 64. So that will give us an LED number to set, and then we just dump that out, and we append it to a list of LEDs that we want to set. And then this function here calls the primary code that just basically sets the LEDs to on. And I have some code in there that toggles them as well. So what you see is if I just swap back to the front end and add somebody else, so if we add Brian, for example, you'll see up there that that's the set LEDs working. It's figured out what positions, it toggles them, and then it sets them to red. So we can look at that. So set LED status here basically just takes this list of LEDs. I've got some code that just does some basic math and says, oh, if it's LED 17, the API works in terms of rows and columns. So, it'd be like that is row number 3, column number 1, or whatever it comes out as. So we build up a list of the actual positions in the hardware matrix. And then I have a function that toggles their color. So setting it just literally turns the LEDs on. We're not using some other data structure in Python to represent the bit array here. We're actually storing the status of the bits in the LED matrix. So there's no backing data structure. So that's add to filter. If I want to see if something exists, we do something similar. So we potentially have to go the full number of hash functions, so maybe all 3. And we do the same thing of we figure out what LED the element we're checking for, or the name we're checking for in this case, hashes to. And then we do a query LED status, which is basically going to tell us if it's turned on or off. If it's turned off, we can fail fast and get out of the loop because we're done, we're finished. So if it's turned on, then we need to keep going. And if we get to the bottom here and we haven't failed, then we've kind of got success, which is it's maybe in there. So let's take a look at query LED status really quickly. So query LED status here, similar thing is it gets the physical position in the matrix of a given LED. And then the API for this product that we've got here has a get pixel function that takes a sort of XY coordinate, and it tells us what is that currently set to. So what are the RGB colors that LED is set to? And then I've just got some code here that basically toggles between whatever those colors are and my querying color. So when I'm looking something up, I wanted this visual effect. So if we do exists really quickly, and we do like, let's do guy again because it will cause it to do the most work. And there it goes. It's flashing one blue. Oh, sorry. It's finished, but it flashed one blue. And let's do Simon. And again, it's flashing one blue, flashing two blue, flashing three blue. Simon may exist in there. That's nothing to do with the mechanics of the data structure. That's just to give it this visual aspect on the pie of like, let's see what the querying looks like. So you can actually see it going through there. Obviously, it makes the data structure on here quite slow, but it's, you know, a fun learning exercise. And then basically, we if it's not set to off, you know, if it's set to anything, then we determine that that LED was on. So that feeds back into the rest of the code, and we use that to determine if we need to carry on or if we need to stop. So yeah, we've got the rest of this code is largely Flask stuff. The front end is nothing special. It's just a little Bulma HTML thing. It calls Flask routes down here to do these things from a form. And if you go to / it just serves up that front end. So that's kind of all it does. If we want to reset the filter, then all we do is basically set everything to off. And the majority of this code here is just a visual effect to flash it blue. So sets all of the LEDs to a specific RGB color. So that's like red 0, green 0, blue 100%. And then we just flash it and turn it off, and that's reset it. So again, there's no data structure in Python storing the state of the bloom filter here. We're literally storing it in the LEDs. So when I reset it, there'll be nothing there. So yeah, what we're going to do with this project is we're going to take it and we're going to change it up a little bit. So what I'm going to do over the course of future streams is remove all of this Flask stuff, keep all of these functions here that have nothing to do with Flask. And I'm going to combine it with something that we did a couple of weeks ago, which I have got here somewhere here. So a couple of weeks ago, we started out by, in our first sort of things on Thursdays, we started out by looking at a bit of Redis protocol and what would it take to write something that pretends to be the Redis server. So we wrote a bit of Python here that listens on port 6379. And what it does is it basically manipulates some data that comes in. We figured out what the protocol looks like, removed some things that we didn't need. And then it understood some commands. So we implemented the command, which is something that Redis CLI sends when it starts. And we just respond with, OK, but, that's great. And then we implemented some of the Redis set commands. So we implemented sadd, add something to a set. We implemented sIsMember, is something in a set. And we implemented scard, what's the size of a set. So we also implemented the world's most basic Redis key space here in an empty Python dictionary. So when I go to set a new or add something to a new set, it will create a new entry in this dictionary and we'd store a set there. So we're storing things in memory. So a common way that people start out with coding stuff that needs set like membership checking is you would start with a set. You'd use like a Redis set or something like that. And then you might find that what you're doing becomes really, really popular, or your data set becomes huge, and then storing all of that set in memory or in Redis, which keeps a copy of it in memory or wherever you're keeping it, starts to become an issue. So a bloom filter becomes kind of an easy and fun swap in for this. So what I want to do over the course of probably next week is take this code here that we'll demonstrate in a minute and the code that we've got with the LEDs and smash them together so that we have something that instead of using this here, we have like a proper Redis protocol talking Python script that understands how to do a couple of bloom filter commands. So it will understand how to do, we'll swap out sadd here for bf.add, which is the Redis Bloom command for adding something to a Bloom filter. And we'll swap s's member here for bf.exists, which is the membership check command. And there's no real equivalent of scard, so how many things have been added to a Bloom filter. So we'll probably get to drop that one. And then what I want to do is end up with something running on this Pi that has a Python script running that anything that speaks Redis protocol can talk to and work with Bloom filter commands. There's two ways I'm thinking of going with this. Is this example here supports different key names. So we've got a dictionary and I can create key names in my key space dictionary and that will work. The Bloom filter up there is obviously a single key because we've only got like one memory space. If we're storing the state of it in the LEDs, I've only got one LED matrix. So I think the thing to do is going to be to give it like a fixed key name. And basically, if you run a Bloom filter command on that key name, then it affects the state of the LEDs. And if you run it on another key name, then we basically just say, well, that doesn't exist, I don't know, and just send an error back to the Redis client. And then hopefully we can eventually write a bit of code on like a normal computer that uses any old Redis client, so Redis Pi or Node Redis or Stack Exchange or whatever we want to do, and have that talk to what it thinks is a Redis server, but it's really talking to our Raspberry Pi that only understands Bloom filters and is obviously a lot slower than a real Redis server, but you know, fun learning exercise. So last thing I wanted to do today was swap over and just run this code here, and we'll see how that works. So let's stop this and let's do what's it called? Python Redis. I'll call it Redis server. That makes sense. So hopefully we've now got a Redis server running on this machine over here, which is 192.168.439. So it's fake Redis server running on our Pi. There won't be any output because it's not connected to the LEDs yet. But what we can do is start a terminal and make it a nice big terminal like this. And what I can do is do Redis CLI and then say minus host 192.168.4.39. And I think we're still on 63.79. What I'm doing here is connecting the real Redis CLI to this Python code that's running on the Pi that's kind of a fake Redis server. So when I do that, I get a prompt up, and what you'll see here in the terminal is, if you remember from a couple of weeks ago, we received this string from the Redis CLI, and we parsed that down to, oh, it sent the command. And that's kind of just what it does to check there's something there. So we just sent it a Redis wire protocol response plus OK. That's like, yep, we're good with that. And you know, it's basically now signed into Redis. So we can do a few simple things. So I can do, for example, sadd call key team, and I can do Brian, and I can do Suze, and I can do Steve. And I think we implemented this so that you can add multiple in one go. There we go. And we got the response that you would expect to get back from real Redis. So we got 3 back. So over here, we parse this out. And we've now got this dictionary set up with a key called team in it, and it's got these 3 people in. So if we try this again, then this time I get 0 because the way that sadd behaves is it tells us how many things were put in the set that weren't there already, and that's 0. Those people were already there. So let's just add somebody else. And let's add in Alex and Josephine. So we've added 3 more people to our set. Given that we implemented a couple of other set commands, we can also say, what's the cardinality of our set? So how many people are in it? 6, which makes sense because we added these 3 the first time, and then we added these 3. And then, I think, did we implement S members? Well, I don't know. Probably not, because that's not something we can do with the Bloom filter. No, we implemented s_is_member. So in a set, normally, when you connect it to real Redis, you could say to it, hey, s_members team, and it will tell you everybody that's in there, because the set doesn't hash the data away. It keeps the actual data, which is both great for accuracy and recall and bad for how much space you take up. So yeah, this one we implemented s_is_member, which is the membership check. So this is something that we can do into the we can do when we transform it to the Bloom filter. So Bloom filter is also for membership checks. We can say s_is_member team Simon. I don't think I added myself. So no, 0, I'm not there. s_is_member team Josephine. Josephine's in the team. And again, the way this works is we are receiving these Redis protocol strings, and we are basically responding with the response that the Redis CLI expects. So what I'm going to do in the next stream is take this command and do lots of copy pasting, or I might do some of it offline in between times, because that's not great fun television, and move this sort of front end into the LED, use the LEDs as storage, and start swapping out some of these set commands for Bloom filter commands. So yeah, that was kind of what I had today. I am extremely glad that the hardware has behaved itself. Last week we had a heat wave here, and we had all sorts of things literally having thermal issues, and that didn't help our live streaming. So thanks for coming back to check this out. This is a project we'll keep moving forwards with. And if there's anything that you want to see on our live channel, which the URL is for below, we stream regularly now on multiple days of the week. I'm usually on Thursdays. You'll quite often catch Savannah on Tuesdays, Steve Wednesdays, Guy Fridays. We come and go a little bit as we head to conferences and do other things, but we're trying to do regular streaming cadence. So if you're interested in this stuff, then come back and see me on Thursdays. If you'd like to chat with us, we have a very active Discord server that, let's pull that up here. We have a very active Discord server where you can get help with your Redis problems, or just come and chat with us about anything coding if you like. It'll tell you when we're live streaming, so you don't miss one of these. And we also have all sorts of channels for, if you have something that you've done and you want to write about it or tell us about it, we have a self-promotion channel, and we'd love to see you in there. So yeah, that's about it for today. So I'll be back next week when hopefully we can do some, connect the Redis CLI to make some LEDs flash. All right, I am going to go and remove the desktop here now. And yeah, thanks very much, everybody. And we'll see you next week. Take care.